Good morning, students. Welcome back to science class on the chapter magnetic effects of electric current. In the previous class, we had discussed about DC motor, the working of electric motor. Okay, so till now we had studied what. So using electric current, we can generate magnetic field. Okay, see from now onwards, using magnetic field, we can generate electricity. Okay, is it possible? We can generate magnetic field using electric current. So now just reverse. Okay, using magnetic field we can generate electricity or electric current. So now we will see that. So today we will discuss electromagnetic induction. Okay, how the current is used. Okay, we'll see. See, as for that, before that, we have to do one experiment, a small experiment. So, you take a pipe like this, okay? Then take a copper wire. Yes, here both the wires are connected to galvanometer. What is that? This is galvanometer. Galvanometer, which shows the existence of current. Okay, if current passes through this coil, then it shows deflections. Okay, so this is a galvanometer, which shows the existence of electric current. Okay, now take one bar magnet. Take one bar magnet. Take one bar magnet. Okay, so now we have to bring this magnet inside the coil. Okay, okay, so now bring this bar magnet inside the coil. So what will happen? See, when you bring this bar magnet inside this pipe, okay, see here these are copper wires. Okay, so now when you bring inside, at that time it will show deflections. It will show deflections. So which means when it shows deflection, at that time we can say that electric current is generated in this coil. Here, see, when you keep here this bar magnet here, what will happen? It shows deflections. Okay, it shows deflections like this. Then once again it will come back to same position. Okay, just means like here. When you bring inside, when you keep that bar magnet inside, just it will show like this, and it will come back to the original position. Now, when you remove that bar magnet from outside this pipe, okay, at that time also it will show the current direction in a reverse order. In reverse order, like this. When you remove that bar magnet from that pipe, so it will show like this, and it will come back to its original position. Okay, so here, when you keep this bar magnet inside the coil, what will happen? It will show deflections. While removing also, it will show deflections, but in another direction. Okay, while keeping, it will show. See, when you bring this bar magnet through near this coil, what will happen? It will show direction in one direction, and while removing, okay, at that time also it will show that direction in it will show direction in see the direction in another. Okay, so now what it indicates? Okay, clearly we can say that due to the relative motion between the coil and the bar magnet, okay, electric current is induced in the galvanometer. Okay, or electric current is induced in the coil. Okay, induced means electric current is generated in the coil. Clear? Okay, so this process is called electromagnetic induction. Okay, see here, when you keep, now see, when you keep the bar magnet inside, see, it will show current only once and it will come to zero position. Okay, then while remaining also it will show the current in another direction, then it will come to original position. So here in this case current is generated in only two times, but we need continuous current. At that time what to do? Here we need that current, we need continuous current, so we need that current continuously. Okay, if you want that current continuously, then we have to keep this bar magnet in a motion, means you have to bring the inside and outside, you have to do like this. Okay, you have to do like this, you have to keep inside outside means continuously. At that time it will show the deflections continuously. See, while bringing inside it will show like this, it will move continuously like this. So then we can say that electric current is induced in this coil, or electric current is generated in this coil. Okay, so this process is known as electromagnetic induction. Clear? So here we can generate electricity. How? Due to the relative motion between the coil and the bar magnet. Okay, you know, here the magnetic field lines are ending, right? Clear? But when you bring here, suppose here and here, what about these magnetic field lines? Even these magnetic field lines also changes, right? Okay, so these magnetic field lines which constitutes to move electrons in the circuit. Okay, sorry, in the coil. Okay, so electric current means what? It is the motion of electrons, correct? So here also when you change the when you change the positions of the magnetic field lines, then current is induces in the coil. Okay, so now here you are changing the positions of the magnetic field lines, right? So that's why that change in the positions of the magnetic field lines. Okay, what happens? The current is induces, or current is generated in the circuit. Clear? Now see here. One more. Now I will keep this bar magnet in a constant, means at rest position. Okay. Now I will keep this bar magnet at rest position. So now I will take this entire coil. I will keep this coil in motion. Means I will I'll take this coil, and once I will do like this. Okay. So at that time, do you think that the current is generated? Yes, at that time also the current is induces, or current is generated in the coil. Okay. See, due to the relative motion between the coil and the magnet, so current is induces in the coil. Okay, so this process is known as electromagnetic induction. You can keep this bar magnet in motion, or you can keep this coil in motion. In both the cases, we will get the current. See, but if you want a continuous current, then you have to keep either coil or bar magnet in motion. Okay, see, if you keep that bar magnet simply inside the coil, at that time you will get current only once. You won't get continuous current. If you want to get the continuous current, then you have to keep either this bar magnet or either this coil in continuous motion. Okay, so then we can generate electricity, or then the current is induced in the coil. So clear? So this is electromagnetic induction. Okay. See, electromagnetic induction means electromagnetic induction is the phenomena in which an induced EMF and induced by changing magnetic field. Like that permanent continuously. Okay. See, for that now we'll make small changes. Okay. See here. Now see, now I will connect one battery here. See here, this is coil 1, coil 2. See here, this is coil 1 and this is coil 2. Now, see here, I will turn on the key. So what will happen? Current will move through this coil. Okay. So now what will happen? Electrons move from negative side to positive side. Okay. So when you pass current through a conductor, what will happen? Magnetic field is created, right? We have seen. Okay. This is just like a coil. So what will happen? So magnetic field create like this. Okay. Just a minute. Here. So now, so clearly we can say that magnetic field is created around this coil. Okay. Now what will happen? See, these magnetic field lines. Okay. If you pass a strong current, then the magnetic field lines increases, right? When you when you increase the current, then the magnetic field strength is also increases. Strength means what? The magnetic field lines increases. Okay. Now these magnetic field lines, see here, they will enter into this coil. Here, these magnetic field lines here, these magnetic field lines, okay, enter into this coil. Clear? So now these magnetic field lines, they will enter into this coil. In this case, now can I say, what the electric current is induced or generated in this coil. You know, earlier you have studied, okay, due to the relative motion between the magnet and the bar magnet and coil, the current is induced. Okay, so we can generate electric current in the coil. Now I am not using magnet, okay, but see, you are using that bar magnet. What is the meaning? Just you are changing the magnetic field lines. So that's why we can generate electric current. So instead of that bar magnet, now I am using, see, that same magnetic field, but I am using electric current. I am not using the bar magnet. Okay. So now in this case, now is it possible to induce or generate current in the coil? Yes, sir, definitely. Okay, these magnetic field lines, they will enter into this coil. Okay, at that time, the current is induces in this coil. Okay, so now here we have generated magnetic field using electric current, and in the second coil we have obtained, see, we have induced current using this magnetic field. Okay, so clear? Here, just here we have passed electric current. Okay, through this coil. What happened? Here the magnetic field is generated around this coil. Okay, and these magnetic field lines, they will enter into this coil. Okay, then these magnetic field lines, they will induce electric current in this coil. Okay, so then this galvanometer, it will show deflections. Okay, so this process is also known as electromagnetic induction. Listen here, if you want to increase more current in this coil, then you have to increase these magnetic field lines. How to increase the magnetic field lines? By increasing the electric current. Okay, so now using electric current, we can generate electric current. Clear? So just here, first we will using electric current, we will create the magnetic field. Then these magnetic field lines, they will enter into this coil, and the current is induces in this coil. Okay, so this process is known as electromagnetic induction. Okay, so now next to move to electric generator. So now we can see here, now we can generate electric current, right? If you do, see here, if you perform activity like this, so definitely we can generate electricity, so electric current. Clear? Now we will discuss the working of electric generator. Here also, this electric generator. Okay, here also we have one rule is there. Okay, that is Fleming's right hand rule. Okay, Fleming's right hand rule. Okay, the first three fingers of your right hand, you have to hold mutually perpendicular to each other like this. Okay, so now see here. See here, in first case, you had studied galvanometer. This is bar magnet. Okay, when you keep this coil in motion, okay, when you keep this coil in motion, okay, at that time also current is induces. Okay, and you keep this coil, I will keep this bar magnet fixed position, and if you rotate, if you keep this coil in a motion, at that time we can generate electric current. Okay, so now see here, just mention these two are bar magnet and these two are magnets. Okay, then I will take one coil. Here so many number of turns are there. When you rotate this coil, between the magnets, at that time we can generate electric current. Okay, so now we will see that one. So this is also very important for 4 or 2 marks. For 4 marks they will ask just to draw the diagram and explain the working of electric generator or AC generator. Electric generator or AC generator. Okay. First I will draw the diagram. Yes, see here. So now here, now this is a ABCD. This is a coil. Okay, a mean number of turns are there. When you rotate this coil, when you rotate this coil between the magnets, so we can generate electric current or current is induced in the coil in the galvanometer. Okay, we have seen right in that experiment when you that bar and bar magnet coil. When you keep that bar magnet rest position, when you keep that coil in a motion, at that time also we can generate electricity or we can generate electric current. Okay, here also we are keeping these two and we are keeping bar magnets at rest position and just we are rotating the coil. Okay, rotating the coil, then electric current is induced in the galvanometer. Now see here. So now you know you have seen a generator, right? Mini generators. Okay, so there this process only takes place in those generators. Clear? So now here this AC generator or electric generator which converts mechanical energy into electrical energy. What is that? Which converts mechanical energy into electrical energy. Clear? Okay. So here this electric generator, okay, which converts mechanical energy into electrical energy. Clear? Yes. So now see here, it works on the principle of electromagnetic induction. You know, right? When you keep the due to the relative motion between the coil and bar magnet, electric current is induced in the circuit, right? So here also due to the relative motion between the magnets and the coil, the current is induced in the circuit. Okay, induced in the galvanometer. So clear? So on that basis, okay. So electric generator, it works on the principle of electromagnetic induction. This is very important. Okay, maybe they'll ask for 1 mark. What is the principle of electric generator? Okay, so electric generator, it works on the principle of electromagnetic induction, and this electric generator which converts mechanical energy into electrical energy. Clear? So this electric generator which converts mechanical energy into electrical energy. Now see here we should rotate this coil. Okay, we should rotate that coil, then current is induces. So now we should know, suppose in which direction we are rotating and in which direction that electric current is generates. Okay, for that we have Fleming's right hand rule. What is that? Fleming's right hand rule. Okay, see here, you have to hold first 3 fingers of right hand mutually perpendicular to each other. Okay, see here this thumb which shows the direction of the coil, means in which direction this in which direction you are rotating this coil. Okay, which shows the direction of the motion or direction of the coil, and this forefinger which shows the direction of the magnetic field, and this middle finger which shows the direction of electrical, in which direction the current is induces. Okay, now see here. Now just imagine, see here, this is a coil. Okay, AB. Now taking this position. Now current is moving. See here, this is AB. Now I will rotate like this. Now first I will rotate like this, which means motion in this direction. What about magnetic field direction? Okay, magnetic field direction is north to south, like this. Okay, now just release this middle finger, just release it. Okay, now see here, now this coil is moving in this direction, means upwards. Magnetic field direction is in this direction. What about current? So now current direction is in this direction. So now current is induces in which direction? That is from A to B. Clear? A to B. You will rotate. Okay, it will come upwards like this. Magnetic field like this. Then current is induces in this direction. That is A to B. Now in the first case, in the first rotation, the current direction of the current is, see here, first it will move A to B, then C to D, then see here, then it will move to R to ring, R2 to then galvanometer. Now here current moves from R2 to R1. Clear? Now current direction. See here, first A to B, B to C, C to D, then it will directly move to R2, R2 to galvanometer, then to R1. Okay. Now see, after rotation, after one rotation, what will happen? See here, this is AB. Okay. After one rotation, what will happen? Now this AB, it will go this side, and CD, it will come this side. Clear? So after half rotation, what will happen? DC comes this side, and it will come this side. Okay, AB. Now let's check what about current direction. Okay, yes. Now this is DC. Correct. You are rotating upwards only. Okay, you are rotating upwards. Clear? So now, see here, it is moving. Okay, see here, it is moving. It will go downwards. Once again, it will come upwards. Clear? So now, see here, force direction, magnetic field direction, then current direction. Okay. Listen carefully. Thumb, magnetic field, then motion. Okay. So now current is, see here, now current is indices in which direction? Okay, that is from D to C. See here, now, sorry here, okay, this is, see here, now it will come this side, okay, D to C. See, initially A, B, and this is C and D. Okay, so after half rotation, what will happen? See, I will show you here one more diagram. See here. Yes. Now see here. Okay. So now this is the first rotation. In the first rotation, current is moves from A to B, C to D, then R2 to R1. Okay. So here these R1 and R2 are slip rings, not split. Okay. What? R1 and R2 are slip rings, and these are carbon brushes for sliding contact. Okay. B1 and B2. Now see here. After half rotation, what will happen? See here. This is AB, it will rotate like this. What will happen? Now DC, it will come this side. Okay. Now DC, it will come this side. Now in this case also, see here. Now see here, AB it will rotate. Okay. Now once again it will rotate. Now this DC, it will go upper side. Okay. Thumb represents the direction of the motion. Then magnetic field. Then current. Then current. So now current is moving in this direction, right? So now current is moving from D to C to B, then B to A, then R1 to R2. Okay. So observe here, earlier in this case, current A to B, C to B to C, C to D, then R2 to R1, R2 to R1. But what about in the second case? In the second case, current direction is D to C, C to B, B to A, then R1 to R2. In this case, current is R2 to R1, but in this case, R1 to R2. So here current direction changes, right? Here current direction changes. Okay, so that's why it is not a unidirectional current. Okay, so that's why we call this is alternating current or AC current. AC current means alternating current. So here the direction of the current changes. Here the direction of the current changes. So that's why we call this as alternating current, or this is AC generator. Okay, so by doing like this we can generate electric current. So clear? See, first case, see, according to your right hand rule. Okay, so just imagine first thing, this is A B C D, A B. So you will rotate this like this. Now then magnetic field direction in this direction, then current is induces. Okay, like this. So current will move from A to B, B to C, C to D, then ring R2 to R1. Now what will happen while rotating? See, it will go this side, AB go this side, then DC it will come another side. Okay, now once again also you will rotate like this. Once again, see here, motion, then magnetic field, then current. Now in the second case, electric current is the direction of the electric current is from D to C, that is D to C, then C to B, B to A, then R1 to R2. So that's why, see here, to change that direction, to change the direction of the electric current, okay, we are using slip rings. Clear? But instead of this one, if you use the split rings, what will happen? You will get electric current in only one direction. Okay, but actually we need AC current, right? We don't want direct current, because all of our machines those depends on AC alternating current. Okay, so alternating current will have many advantages over direct current. Okay, so you will study in higher classes. But here we need AC current, so that's why we have to change the direction of the electric current. So that's why we are using slip rings. Okay, not split rings. These are slip rings. Okay, so now how to generate? How to see? Now we need more electric current. How to increase the current? So one, when you increase the speed, if you rotate with a huge speed, then electric current increases. Then if you use powerful magnets, high power, very strong magnets, at that time also we can increase the electric current. Okay. Now see here, but how to rotate this coil? Okay, how to rotate this coil? You know, we can't rotate continuously. Right? We are humans. Okay, we need voltage in the level of 10,000 like that. Okay, at that time, how to generate? We need current in megawatt, gigawatt, in that order. Okay, you know, we had studied what sources of energy. Correct? You know, first you will burn that coal. Okay, that steam is produces. You will pass that steam to turbine. Okay, then that turbine is connected to generator. Correct? So that turbine is connected to this coil. Now how we can generate electricity in a thermal using thermal power plant? Just to rotate this coil. So this coil is connected to turbine. Then we will pass the steam to this turbine. Then electric current is generated. Clear? Then if you take a hydropower plant, what will happen? Hydropower plant, just water flow, right? See, the water will fall from high position. There we will keep on turbine. Okay, then this turbine is connected to what? This coil. Okay, when it starts to rotate, at that time also even this coil also it starts to rotate. So then we can generate electricity. Clear? Okay, so there we have studied so many energy sources, right? Thermal power plant, hydropower plant, then wind energy. You know that fan in wind energy. Okay, wind energy, those fans. Clear? Okay, so if these fans rotate, right? So here this fan is connected to this coil. Okay, when this fan rotates, at that time this coil also rotates, so we can generate electricity. Okay, so using our own muscular energy, we can't rotate. We can rotate, but we can't generate that electrical high electric current. Okay, so that is impossible for humans. Okay, to rotate this coil we have to use those energy sources: thermal power plant, hydro, wind energy, solar energy. Solar energy is different. Okay, then geothermal energy, wave energy, tidal energy, okay, nuclear energy. All we are using those source of energy just to rotate this coil. Okay, see, those are different. Thermal power plant is different, hydro is different, geothermal is everything is different. But finally, we are using those energies just to rotate this coil. So clear how we can generate electricity from those energy sources like this. So clear, right? This is the working of electric generator or AC generator. Okay. I think time is over, so I will stop here. So tomorrow we will study DC generator, how we can generate direct current. This is electric current. Okay, so now this current, graphically we can show this electric current. See, like this. Graphically we can show this electric current like this. See here maximum current, less current, and here maximum current. Why we got this kind of? Because in this case current is, see, A to B, that is R2 to R1. But what about in the second case? The current direction is from R1 to R2, that is D to C. In second case, the current direction of the current, it is reverse, right? So that's why we represent graphically like this. Okay. So the working of AC generator. We will meet in the next class. Thank you.